What we're going to do now is we're going to take the trusses that you are creating for our truss project, and we are going to kind of put them in a simulation to figure out how the forces are interacting in your actual truss. So we can kind of predict where things are going to break and maybe use that data to create better trusses. So on your desktop, you're going to find MD Solids 4.0, should be right on your desktop, and I'm going to double click in there to get it going. For some of you, a registration might pop up, in which case you can put in whatever username you want, doesn't really matter. If it wants a registration code, use the one that you see on the screen. So D93C8ADC, and that will give you full access to MD Solids. And that may not pop up, it just kind of depends on what's going on. So let's go to trusses. I'm going to click on this module right here and get everything ready to go. Okay, so let's build our first truss, and I'm going to do truss number 1 for our work right now. I'm going to hit new truss. So you'll notice that the defined truss grid is popping up. So what this is asking us to do is it's telling us to determine how many spaces we need that go across the bottom and how big do we want that represented. Now there's kind of a couple ways of doing this. What I'm going to do kind of the easy way since we already know a lot of our information. I know that we need a total span of 9.75. I know that the middle is going to be kind of where our top joint is at 4.875, and I know that we're going to have an overall height of 2.75. So I'm going to try to keep it as easy as possible. So I know the distance, horizontal distance from the corner to kind of the top spot is going to be 4.875. So I'm actually going to make my spacing interval that. And I want 2 spaces, right? So we have 1 space from the end to the middle, that's 4.875, and then another that's 4.875 to give us our total of 9.75. It'll make a little bit more sense once we actually see it in action. Vertically, I only have the 1 joint, so I'm just going from the bottom to the very, very top. So again, I'm going to make my life easier. I'm just going to say 2.75, and there's just 1 space. And I'm going to hit OK. So notice we have our numbers over here. We have 0 all the way out to 9.75, which is the total distance that we want. We have our midpoint right there. And since we don't have any fancy structures in between, we just go right up to 2.75. Now over here, this is where we actually build our truss. And you notice that we have 5 options. We have create, erase, members, supports, and load. So let's create our members to start off with. So make sure that create is checked and members is checked. You always have to start on the kind of the little intersection right here. So I'm just going to click and drag, and notice how it creates the joints for us automatically. I'm going to click and drag. I'm going to click and drag. So that's our basic truss number 1. Now, for whatever reason, if you mess it up, we can go to erase. We can select from joint to joint, clicking and dragging. And when I release it, it gets everything out of there. So I'm going to go back to create, because that member was okay, and we'll make sure that looks good. So we've got our 3 members. Obviously, if you're doing truss number 2, you have a different design that you're dealing with. Let's create our supports. Now, we're going to learn about this later on, but every bridge is going to have what we call pin and roller supports. We don't really need to know about that. Just kind of follow along with what we're doing. So we need 1 pin and 1 roller joint. So to create that, I'm going to make sure that I have create and supports. I'm going to take this joint where our truss is being supported. I'm going to click and drag straight down. So we have, this is called a roller joint. And I'm going to click and drag straight to the left. So it creates what we call a pin joint. And I'm going to do kind of the same thing, basically half of that on the other side. I'm just going to click and drag down, and notice how it's oriented just like this. So this is our pin represented by a triangle, and this is our roller represented by the circle. Now, if we need to change it, right, we can take out either of those under the erase idea. I'll get that set up. And last but not least is we need to tell the program where our load is going to be. So you're going to put your truss destroyer on the very top joint, going straight down, and let's just throw 100 pounds, 100 newtons, whatever that is. Doesn't really matter in that spot. So we have our members, we have our supports, we have our loads. Let's hit compute. And this is going to tell us the forces that are acting on my truss. So these are what we call reaction forces that we'll get into later. And these are the forces that are occurring on the truss itself. Now I notice there's a lot more force going on in these compression members versus this tension member. So my guess is we're going to be cracking on one of these two sides. Now once you have this done, remember to take a snip of it like so, save it, and put that into your engineering notebook so there's proof of forces that are interacting in your truss that we can go back to.